Good day, this is Mr. Sithole. So today we're going to look at numbers, grade 10 numbers, and we're going to look at the real numbers, what is it, and on your real numbers you have the rational and irrational numbers, then also you have non-real numbers. We're going to look at that. Then also want to know how do we round off number line and interval notation. So okay, let's get to see what's going on here. Now, natural numbers. So natural numbers are your positive numbers from 1 up until infinity. So you are adding 1, any number up and up above 1. Then the whole numbers now include 0. The whole numbers now include what? 0. So you have something that is special there. There is an additional of 0. Okay. Now you can also see we have n 0 as a symbol for that. Then integers. So we normally use these symbols here. This one here is the one that you actually be seeing in most cases. Okay, now let's get to it now. The integers, these are, numbers from negative infinity to positive infinity. So it doesn't include a decimal. It's all, they all have to be whole numbers, okay? But now you're now adding the negative numbers. Now, rational numbers, these numbers can be expressed as a fraction. They can be expressed as a fraction, and you can see now what you call A has to be element of integer, and also B is also to be an integer. Mara B must not be equal to 0, because once we have 0 there, it means that it's undefined. Now, what are examples of rational numbers? Whole numbers and integers. So here we are saying all these two here, they fall under what? Rational numbers. Okay, then we have improper fractions, proper fractions. So proper fractions is more like we are saying maybe let's say 2 over 4, 2 over 3, you can say mara 2 over 4, we can simplify it. So maybe let's say 2 over 3. Then when you're talking of improper fraction or a mixed fraction, improper fraction, now we are now saying a bigger number is on top, so a smaller number is carrying a bigger number. That's why I'm saying it's improper. So like, for example, 7 over 2. Okay, 7 over 2 is an example of improper fraction. Then we have a mixed fraction. Now, if we want to write this as 7 over 2 in terms of a mixed fraction, we now say 2 into 7 is going to give us 3. And 3 remainder what? 1 over 2. That's one is now a mixed fraction. Okay, that's how we represent a mixed number. Okay. Now, what about terminating decimals? Terminating decimals, what does this mean? They do end. They do what? End. For example, terminating decimals 0.25 is a terminating decimal, does end. 0.75. These are example of what you call terminating decimal. What about recurring decimals? Now, when we're talking of recurring decimals here, we are now looking at the number after the comma, they do repeat themselves. For example, we are saying it's maybe 1,3,3,3,3 goes on like that. Okay, it goes on like that. But how do we see these? How are these represented in short? We can see if this is 1,3, we find that it's 1,3 with a dot on top. So this indicates that we are going to be repeating this 1, the 3, 3, 3 is going to be repeating itself. What about if it's maybe, let's say it's 0,4, 5, then 4, 5, 4, 5, it continues like that. What does this mean? They can show you it like this, 4, 5, meaning we have a dots on top. Okay, so once you see this, you know that these are recurring numbers. Okay, recurring decimal. Now then, let's look at the irrational numbers. Irrational numbers is now non-terminating and non-recurring. So here they don't end. So they don't end, no ending. So it's until infinity. So it doesn't end. No end. Then here, recurring here, it means that they are not, numbers are not repeated after the comma. So you can have any random 1, 2, 3, 4, 109. It doesn't have any order. Okay, so in that case, we actually call it a non-recurring decimal. Square roots of numbers that are not perfect squares, cube roots. Okay, for example, we can say square root of 10. Square root of 10, if you have to punch it in your calculator here, if you say square root of 10, you see what you get there. You get something that does not end and doesn't have any form that is follow. Okay, now let's look at also including also pi is part of irrational numbers. Okay, now let's look at real numbers. Real numbers now, remember what we said, real numbers now, it includes your rational and non-irrational numbers. Okay, rational and irrational numbers. But now, what about these numbers that are not real? So we call these non-real numbers. Now, non-real numbers, square root of negative number. If we say negative, let's say root of negative 3, root of negative 4, we can't have an answer for that. Or division by 0. Now, division by 0 is undefined, 2 over 0. 18 over 0. So here in this case here, even if you punch in a calculator, they indicate this. So once you do this in your calculator and it gives you error, then it shows that it's a non-real value. Okay, so it's also another way of testing whether a number is a real or a non-real if you don't understand it very well. Like for example, if you say here, if you say 8 over 0, we also see that it's a math error. Okay, let's continue and see what we have on the next page. Now, state whether each of the following numbers are rational, irrational, or neither, meaning to say they will be non-real. Non-real, okay? Now, what about cube root of root 33? So what we do here, we're going to go to our calculator and punch what cube root. So cube root, where is cube root here? Cube root, so it's shift cube root of what you call 33. Then what do we get? We get 3,2075. Let's just write it here. 3,2075. It continues like that. 3433. So let's see here. 3433. And you see that it doesn't follow any trend here, and there is no repeating numbers after the comma, so we call this an irrational. So here let's just call this 1. Let's just call this 1 and call this 2 and call this 3. Okay, and now on this first one here, we are seeing that it's an irrational, so we represent it with the 2. Then what about pi over 2? Again, we need to punch it in our calculator and say, okay, shift pi over 2. What do we get? We get 1,57. Again, this one is not part of the what rational numbers, it's an irrational number. Here, when you see this, it's 4,0 what is it, 013. If you have to punch it, let's just try to punch it and see if we can this can be represented as a fraction. 1345. What do we get there? Even if we try to put it as a fraction, it can't. So here we have our 2 is a non-rational, again irrational, sorry, number. Then what about the root of 1 over 121? Root of 1 over 121, we punch in our calculator. Root of 1 over 121, what do we get? We get 1 over 11. And can you see now, this is 0, what is it? 09, and you can see that it's repeating itself here, and also here we can see it also shown as a fraction. So once a number can be represented as a fraction, it is a rational number. So here we have our 1, because we can put it as 1 over 11. Okay, it can be represented as a fraction. Okay, let's move on to the next one. Now let's try to round off our values. How do we round off? So whenever you're rounding off decimals, let's say they say round off to the nearest 2 decimals or 4 decimal places. You're counting numbers after the comma. So let's say just 2, 3, 4, 5. And another one, let's say is 2, what you call 3, 4, 3. Then let's just try to round off these to 2 decimal places. So we look at the third number, the one that we look at, third number. We look at the third number here. So if a number is 5 and above, it adds 1 here. You are adding 1. So here, what happens here? This will add, it will be 2. So let's just use this one here, 2, 3, 5. So then we ignore the rest. What about here? What do we see here? We see that 3 is below 5. So it's gonna be, it doesn't change anything. So if it doesn't change, if it's below 5, you eliminate it. You remove it with whatever after that number, you remove it. So you're just gonna be left with 2,34. Okay. Let's try to practice here and see if we can get them correct. Around these 3 decimal places. So when you count, how many decimal places do you need? You need 3. So you need 3. So what must you look at? You must look at this number here after the 4th number. And what do you see on the 4th number? It's above 5. So when it's above 5, it adds, it increases this number by 1. So it's going to be, 6. What about here? 2 decimal places. You need how many decimal places here? You need 2 decimal places. And how many are you seeing on the, what is the 3rd number here? You're looking at this number here after what you call the second number. So here we are looking at 3, and 3 is below 5. So does it make any change? No. So it's going to be 67,24. What about here? 4 decimal places. How many decimal places are you looking at here? You're looking at 4. So you're counting numbers 1, 2, 3, 4. And which number are you looking at here? You're looking at the 5th number. And the 5th number is 5. It's 5. And it's, remember, when it's 5 and above, what happens? It is 1 day. So it's gonna be 4,3769. Okay. Let's look at this and see what we have here. We are looking at how many numbers here? 5 decimal places. So 1, 2, 3, 4, 5. So here, let's look at this and see. We're looking at 5 numbers of the comma. Then what happens to the which number do we look at? We look at 8, the 5th number. So what happens here is that it's gonna add a 1 day. Then if it adds a 1 day, it's gonna be 10. Now, what happens now if it's like that now? Let's see what we have here. It's gonna be 17,247. Now, here, once we have a 10 here, a 10 will add another 10, or add 1 here, which is what you call, it's gonna give us 4, and it's gonna give us 40. Okay, it's gonna give us 40. So that's what you need to do here. Whenever it's 9, you know that you are adding a 10, but now on that 9 here, you replace it with a 0. Okay, that's what you always have to remember, because we need to be left with the 5 numbers of the comma. So let's say you got a whole number. Let's say they ask you to give your answer 2 decimal places, and you get your answer is maybe, let's say it's maybe 27. So it's gonna be 27,00. Why this? Because it has to be 2 decimal places. Okay, so that one not to worry about. Then what about if it's 3 pi? Remember here, you punch it in your calculator, 3 pi. So you just punch, it's a hint that I'm just going to give here. You punch in your calculator here and get your answer. Then you see 3 decimal places, so you're going to be left with 3 decimal. Then you look at the 4th number, which is 7 is going to add 1 here, it's going to be 5. So it's going to be 7,425. Okay, that's all that you need to do. So here I gave you a hint, punch in your calculator. Let's go to the next question here. Without using a calculator, determine between which 2 integers the following irrational numbers lie. Okay, then verify your answer by using a calculator. Now, what you need to understand here, when you're asked to find 2 integers, between irrational number, you need to check here. You need to look for perfect square. For this one here is a square root of 50, but you don't have a square root of 50. So what do you need to do here is that you need to check, okay, which 2 numbers are below, the next number below 50 and above 50, which is a perfect square. Close to 50, two numbers. Now, one below is going to be 49. So we have 49 here. So we've got root 49, root 50. And what is the next one? What we have root 45, then it's going to be root 64. So these are numbers that are perfect squares after 50. So close to 50, we have got a perfect square, which is 49, and another perfect square, which is what? Which is 64. So here, what we will get here, root 49 is 7. So what you call, so 7, and what else here do we have here? We have got 8. So it's between 8, 7, and 8. So, okay. Now, let's look at the next one here. Let's look at the next one here. So, fifth root of 30. And now, if you had to check here, the one number that you've got the fifth root here above 30 is 32. And the number that is the fifth root below 30, the only thing that we can think of here is 1. So you've got fifth root of 1 is 1. Then here you've got fifth root of 30. Then you have got what here? 2. So if you are to punch in your calculator here, 2 to the power of 5, you get 32. So 32 is close to 30, and is the one that can give us, what is it? That is close to that. Now, what about cube root? Cube root of 45. Which two numbers are lies which have got cube? So I'm going to give you one of them here. I'm going to give you one of them here, please. I'm going to give you one of them here, which is going to be, what is it? Below 45. Below 45, what can we think of? It's going to be 27. So 27 is something that you need to know is below that, and is give us 3. Okay, so let's continue. Here you need to check the other one, which is above 45. Okay, now let's look at this. Find a rational number between 3 over 5 and 2 over 3. So what must you do here? You must look for what you call lowest common denominator. Lowest common denominator is a number that your two denominators can go into. 5 can go into that number, 3 can go into that number, but the smallest number that we can think of is 15. Now, if it is 15 here, we now have our common denominators here, 15. We now have 15. But how do we get to 15 here? We need to multiply here by 3. We also need to multiply here by 5. So we do the same here on the top one. We multiply also by 3. We multiply also by 5. So what do we get here? 3 by 3, you get 9. And 5 times 2, you get 10. Okay, you get 10. But now, is there any number between 9 and 10? We don't have. So what must we do? We must double. So let's double. Now, when we double here, we are multiplying everything by 2. When you double here, your answer here that you get 18 over 30, then, and what? And 20 over 30. Now, when you have got this now, you can see now that you have a number that is between those two values. You have a number that is between 18 and 20, so which is 19. So 19 here becomes our what you call a rational number between 3 over 5 and 2 over 3. So its answer is 19 over 3. I hope you understand how we get this. So first of all, you equate you find the lowest common denominator. Then secondly, now we are looking at what you call your top numbers. If there is a number between, if there is no number between, you double. If there is no, again, you triple. But normally after doubling, you must get your number. Now let's look at what we know as number lines. Now, I think you have seen this is part of inequality. You are showing, when it's shown like this, it's part of inequality. But again, here, we need to understand what does this mean is -1 less than x less than what you call 12. So here we can have, we don't need to worry much about everything here. We need to put our 0 there. We need to put our -1 there. We need also to put our 12 there. Okay, now we have something that we can work with. Now, here we are representing this on a number line. Now, whenever you are not including, including the value. So if there's no or equal sign here, we just draw an empty box. We draw an empty box here, then we draw another empty box here. Okay, now when you have the empty box, we need to connect these two. We need to connect these two. That's our answer like that. What about here? What do we see here? -3 to to 1, real numbers. Okay, let's have our our 0 there, our -3, our 1. Okay, let's see here again what we need to do here. What do we need to do? We need to represent this here now, because there's an equal sign, we including that number. So we shade the box. Mara here, because we're not including the -1, we just put a 0 like that. Okay, so let's connect our values like that. Now, here we're looking at natural numbers, and natural numbers here we don't have 0. So we don't have 0. And negative numbers, we don't have that. So no 0, no negative numbers. So here, what must we do now? We need to know that, okay, we are saying x less than 7. So what do we need to do here? We need to have something to work with. So 0, we can't deal with it. So we can only deal with from 1 to 7. So now again, we're going to draw our values here. So if ever we are defining this area, these values, x less than 7, it means that we are not including 7, but here we need to include a 1. Because it's between, it's less than 7, and it's gonna include your 1, not 7. That's how we show on our number line. Okay, let's go on to our last slide, interval notation. Now, I think you have seen that in some cases, when your inequalities or on your functions, you need to define your range, you need to define your domain. And in that case now, sometimes you use what we call interval notation. For example, here, we can just say, let's say it's 1 less than x less than 4. So in that case here, we can write it like this, or we can write interval notation where we just say 1, 4. But now, because we are not including the 1 and the 4, we just put a bracket like that. But now let's see if we are including the bracket. Let's say we have -1 less than or equal to, maybe let's say x less than or equal to maybe 27. Now in this case here, we're going to write -1, 27. And what do we do here? We put this kind of brackets. Okay, that's what we represent with it. It's no longer just a bracket. We put that bigger bracket. Now let's see here, what are we going to do here? Once you see a dot means that it involves 7. So what must we do here? On this side here, we must have this kind of bracket, -7, 9. And you can see there are different brackets. Different here, 9. So let me just try to use maybe a different colors here, so that you understand something here. So here is a bracket. Here it's a 4 corner, like what called with a corner there. Now let's see here what we have here again. We have a bracket, then what called different form of bracket. Then here we have something like this. Then it's actually surrounding what we have got -2 and what is it, and 11. So once you see this, it shows that including 11. Okay, so this is part. All right, now in this case here, now we are having, when it's continuing like this, it means that the arrow is up until infinity. So in this case, it's positive infinity. This one is up until negative infinity. That's what it means, guys. So whenever you see that, that's arrow goes on like that, it means that it's until negative infinity, or here until positive infinity. So how do we represent this what you call in the interval notation? Because here we are worried much on the interval notation. Okay, now how now do we represent this? Let's see here what we're supposed to do. We're supposed to start by writing -6 here and our comma there, and we have positive infinity. Now in this case here, you put a bracket, normal bracket here. Then here, since you're including the -6, you must put what is it, that corner bracket. Now here, when we have got what is it, we are now starting with our negative infinity. So we are starting with negative infinity here, negative infinity. Okay, again we put a normal bracket here. When we are given something like this, we know that it's 1 and 1/2. But how do we represent the bracket? It's also a normal bracket, because it's not involved including the value here. Okay, I hope you guys understand this lecture. Thank you so much. All the best, guys. See you next time.